this part 1 of the practice final. 1 through 20 are multiple choice, so the last 6 to 10 or so are going to be do your own work, show your work. Alright, so number 1, Wally constructed a 90% confidence interval on the mean number of defects at his trash bag factory. The confidence interval is this. What would have happened to his interval if he increased the confidence level to 95%? Alright, if he started at 90 and went to 95, the interval would have widened. Alright, remember the confidence intervals are based on area in a bell curve. So to get more area, we have to go out further. Okay, so the confidence interval would have widened. Number 2, determine the probability z is greater than 1.34 using the standard normal table or your calculator. Alright, we went over the standard normal table in class, but I showed you guys how to do it on the calculator. It's a little bit more precise and accurate. So go to the distribution menu, DISTR, and then select normal CDF. If it's Z, it would be normal CDF. Alright, and then we would do 1.34 comma 999. Alright, and then that's 0.0901, so that would be B. Oops. B. Just again to give you a little visual, Z 1.34, that would be somewhere around here, right, a little bit above 1. And then if it was greater than 1.34, that's everything above it. So remember, when you do the normal CDF, it's where does the shading start? It starts right around 1.34. Where does it end? The 99999 again means it doesn't end. So that's how we could put that in our calculator to do it. Alright, a 6-sided die is numbered 1 to 6, 1, 3, and 4 are red, 2, 5, and 6 are green. The die is rolled once. Find the probability of getting a green or the number 4. So if we got 3 ways to get a green, and then there's the number 4, that's 4 out of the 6. And that reduces down to 2 out of 3. So that'll be option B here. Alright, determine the value of C that makes the following a probability distribution. Right, remember, for any distribution of values, possible values of a variable, to be considered a probability distribution, these probabilities have to add to 1. So to find out what that would need to be to get it to add to 1, we just subtract the other values. So 1 minus 0.36 minus 0.47 minus 0.12 gives us 0.05, which is C. Alright, hypothesis test is conducted. A p-value of 0.061 is calculated. If alpha is 0.05, what would be the appropriate decision? Alright, in this case, p-value is greater than alpha, so we fail to reject. Alright, remember, the way it goes is p is less than alpha, which is the level of significance. Then you reject. If the p-value is greater than alpha, you fail to reject. Alright, and that's what we did here. The p-value 0.061 is greater than alpha, we failed to reject. Okay, just so you understand, we never ever do these. We never accept, and we never fail to accept. Okay, so the only options are going to be reject or fail to reject. Okay, then that's the way you determine which one you do. Alright, an experiment was performed to determine what type of, or if the Toyota's newest Camry model would pass the new level of emission standards, and what type of data is collected. Alright, to collect data on this, we're collecting the emission standards on the Camrys, and that's a measurement. Alright, so measurements are continuous. Sample variance. So when I see a data set, I'm going to throw that into my editor, and once I have it in there, stat, scroll over to one variable stats. Now, remember, variance is not on here anywhere. The only thing that's on here is the mean. There's sample standard deviation. That's population standard deviation. Okay, so this 3.06 to two places, 3.07 is not the variance, it's the standard deviation. So to get the variance, we have to take that 3.067, I'm going to round it to 7, and square it. And that gives us 9.410. So that's the variance. You have to square the standard deviation that's given. All right, and specifically you have to square this one because this is population. So this is sample, so we have to use the sample variance. So 9.41 is our answer. Alright, range. This is about the easiest question on the test. Range is the largest number in your set minus the smallest number in your set. So 16 minus 4 is 12. Dr. Easytime gave a chemistry test. The mean score is a 78. The standard deviation was 11. Would it be unusual for a student to score lower than 54? Why? Alright. Remember what we said as far as standard deviations goes. 2 or more standard deviations from the mean. Is unusual. So 2 standard deviations from the mean here, 78 minus 22 would be a 56. Alright, and 54 is more than that. So 54 is more than 2 standard deviations from the mean. So that would be considered unusual. Alright, a sample of 30 duck-billed platypuses. The mean weight was 84 pounds, sample standard deviation of 2.1 pounds. We want to construct a 95% confidence interval for the population mean weight of duck-billed platypuses. Okay, so remember for these last types of things, the confidence intervals and hypothesis test, if you're doing a confidence interval, you ask yourself a couple of questions. You ask yourself first, is it for a proportion or percentage? Right? Is it? No. Confidence interval for the population mean. So, no. Right? That means it's going to be a Z interval or a T interval. Alright, and then once you determine that it's not for proportion, you ask, do I know population standard deviation? Alright, now, in a sample of 30, the mean weight was this, the sample standard deviation was this. No, we don't know the population standard deviation. We know a standard deviation, 2.1, but it's not the population standard deviation. This question is specifically population. Every data set has a standard deviation. It's just, is that data set a population or a sample? In this case, it's a sample of 30. It's a sample standard deviation. So we do not know. So that means that this is a T interval. Okay. If it's a Z interval, then we do know the population standard deviation. But if we don't, it's a T interval. So we go to our calculator. Alright, the intervals are over here in the test menu. It's not a T test, it's a T interval. Alright, do we have data or we have stats? We have stats. Data would be a list of numbers like we see in the couple previous problems. So we have stats. They want to know what's our sample mean. Our sample mean was 8.4 pounds. What's our sample standard deviation? It's 2.1 pounds. And what was our sample size? 30, which guarantees us that nice bell curve shape. Alright, we want a 95% confidence interval, so just leave that at 0.95, or change it if yours is not at 0.95. And then calculate. Alright, and we see that once it gets done thinking, it takes a little longer for T intervals. we get 7.62 to 9.18, which is B. Alright, mode. The most frequent number that occurs in a data set. If you just count it up, 5 occurs 3 times, nothing else occurs that many times, so 5 is our mode. Alright, this will be the last one for part 1. In a sample of 520 residents of Wallington, 241 have digital cable TV, and we want to construct a 90% confidence interval for the population proportion of Wallington residents that have cable TV. Alright, remember, just like before, you ask yourselves the questions. The first one you ask is the confidence interval about a proportion or percentage? Alright, confidence interval for the population proportion. So the answer to this is yes. Alright, if it's yes, that's great, because that means you use a 1 prop z interval. Alright, prop stands for proportion. So stat test, not z interval, but a 1 prop z interval. Okay, 1 prop z interval. Alright, and once you're in here, you can think of prop, the PROP, as proper fraction, because x has to be smaller than n. Okay, so 241 over 520 is the proper fraction that we're talking about here, but that's not a confidence interval. That's just the number in the middle of the confidence interval. But the 241 over the 520 is the number that we're looking for, and we want a 90% confidence interval. So change it from 0.95 to 0.9, and then tell it to calculate. So there's our confidence interval, 0.4275 to 0.4994. That's C. Alright, so that's the first 12 on the practice exam. Part 2 will have the rest of the multiple choice part.